So here we were asked to determine how much is in the account after 2 years, depositing $3,000 into a savings account that earns 6% annual interest. And we want to find out compounded annually. When we find out compounded annually, that's n equals 1. I got $3,370.80. And I just put it into this formula right here. That's the one I remember all the time. A equals 3,000 times 1 plus 0.06 over 1 raised to the 1 times 2 power. Semi-annually, n equals 2, and I got $3,376.53. And I found that by saying A equals 3,000 times 1 plus 0.06 over 2 raised to the 2 times 2 power. And then the last one, daily, n equals 365. I got $3,382.46. A equals 3,000 times 1 plus 0.06 over 365 raised to the 365 times 2 power. And that's how you get those 3 answers. So hopefully you got the same, and we're ready to talk about compounding continuously. Now, compounding continuously means your money is constantly being looked at and making more money. And our formula for this is A equals P times E raised to the RT power. So remember though that E is a constant. It is not a parameter, it's not an unknown, it's not a value that changes. It is a constant. And I call this PERT. A equals PERT. Just because it's easier to say P times E raised to the RT power. It's a little bit of a shortcut to say PERT. So sometimes math teachers will say that. Here's an example. A sum of $100 is placed in a savings account at 5% compounded continuously. That's our key right there. Compounded continuously. Compounded continuously means we're talking about PERT. A equals P times E raised to the RT power. It is only E that is raised to the RT power. Assuming no subsequent withdrawals or deposits, when will the balance reach $150? So our principal, our initial amount is 100. Our end amount is 150. Our interest rate is 0.05. And the fact that they're asking us when means we do not know what the time is. We don't know how long it is. So we're going to put 100 in for A. I'm sorry, 100 in for P. We're going to put 150 in for A. And then we've got our interest rate is part of the exponent, and T is unknown. So let's do it. We've got 150 equals 100 times E raised to the 0.05 T power. My base is E, my exponent is 0.05 T. I'm going to divide both sides by 100. The zeros cancel out, and I have 15 over 10. Now this is one that I may reduce because 15 over 10 is the same thing as 1.5. So I might reduce this one, but it's okay if you don't. We're going to write this in log form. So we're going to have log base E, that's a natural log, of 1.5 equals 0.05 T. I'm running out of a little room, so I'm going to come over here. Log base E of 1.5 equals 0.05 T. Log base E is the same thing as natural log of 1.5 equals 0.05 T. Whatever the natural log of 1.5 is, I'm going to divide it by 0.05. So I'll show you how to do this in your calculator. We've got the natural log of 1.5. Whatever that value is, that's the value. You're going to divide it by 0.05. Now you can do this all at once. You can hit natural log, and then I use parentheses around the argument. I usually do that when I'm working with the algebra as well. And then divided by 0.05. This way it doesn't confuse. No matter what calculator you use, if you put parentheses around the argument, it's not going to confuse the divided by 0.05 with the argument. It's going to first find the natural log of 1.5 and then divide that result by 0.05. And we press enter, and our time is 8.109 years. 8.109 years. $8.109 Now, how did we know this was years? Because when we're talking about money and these compound interest formulas, time is always in money. Okay, we have one last try. How long will it take to double 8,500 at an interest rate of 4.5% compounded continuously? See if you can try that one, and then come on back for the answer. So make sure you're pressing pause. Okay, our answer is, make sure you press pause if you haven't done that yet. If you're back to get the answer, it is 15.403 years. And I'll quickly show you the setup. We've got 17,000 equals 8,500 times e raised to the 0.045 t power. I'm going to divide both sides by 8,500, so we end up with 17,000 over 8,500, boom, boom, equals e raised to that exponent. So we've got the natural log of e, log base e is natural log, not of e. The natural log base e, the natural log of 170 over 85 equals 0.045 t. However, 170 over 85, that's the same thing as 2. And remember earlier I said that doubling, 2, doubling. It happens every time. The doubling time is the natural log of 2 times the rate equals the rate times time. Natural log of 2 equals the rate times time. So we're going to divide by that rate. And there's the work that shows us that time is approximately 15.403 years. So hopefully you found that helpful, and you can see what's coming next. We've got exponential growth and decay on the way.